Hi, I'm Alex Pault of ECN Magazine, and I'm here at the Embedded Systems Conference for a little preview of some new technology coming out from MicroChip. I'm here with Fanny Duvenhagen. He's in charge of product development here at MicroChip, and they're announcing their new 8-bit devices, the PIC18 K22 family and the PIC18F K90 family. Now, I understand, Fanny, that the PIC18 K22 family is an especially low power, low sleep current device specifically designed for highly efficient applications that require something that can function at such low power levels.
Yeah, we've done a lot of work on reducing the power consumption of our products, and it started last year when we announced our XLP technology, specifically focusing on standby currents and static currents. Since then, what we've done is we've done a lot of work on our dynamic power consumption, and the PIC18F K22, along with some earlier announcement this year on our PIC16 products, really is bringing that to the forefront, where we're really achieving industry-leading dynamic current consumption numbers of 50 and 75 microamp per megahertz.
Very nice. Well, one of the things that I had expressed earlier before we started this discussion was the plethora of 8-bit devices out there, that there was a danger of some commoditization going on, that the prices would start to fall without any real benefit to the engineer. But I see with these devices, it's more just that you're expanding the capability sets, you're letting them do more, so it's more that, yes, there are commodity devices out there, but you can still find high-performance devices in the 8-bit space.
Yeah, 8-bit microcontroller is much more than just a digital little microcontroller that people typically associate with 8-bit microcontroller. It really is kind of an 8-bit system on a chip. You know, there's obviously different segments of the market. Our microcontrollers do participate in the really cost-sensitive applications as well. But with these devices, they're fairly feature-rich. As I mentioned, the differentiation with regards to the power consumption numbers that really is industry-leading for any microcontroller, never mind if it's 8-bit or 16 or 32-bit. But also the peripheral set that we've integrated on these devices. We have more 8-bit timers than we've ever had on our 8-bit product. We have more PWM channels than we've ever had on our products. We have 12-bit ADDs on these products. So they really is very sophisticated devices, although they're still pretty easy to use, and all the benefits that you typically associate with an 8-bit microcontroller.
Right, so it's more than just the microcontroller, it's also the DA channels, it's also the various other system, give me a description of some of the other devices that are on the chip.
So some of the other things that we have, we still use integrated EEPROM, so the device doesn't have to wait for the flash memory to write something in non-volatile memory. We have a charge time measurement unit that's used for capacitive touch sensing, and amongst other things, also interesting applications like measuring cable lengths and those kind of things. As I mentioned, the PWMs and input captures there's just a host of them available, and people use these for a lot of different things, whether it's motor controls or buzzers or driving LEDs and other things that they interface to the product. Some of the other highlights on the products is just multiple communication peripherals. We have 2 I2C, 2 SPI, 2 UARTs. It is our enhanced UART module that's also good for automotive and LIN. The products support 1.8 volt at the bottom and 5.5 volt at the top, since there's a lot of people that still have concerns about signal to noise ratios.
A wide power input is a very, very useful thing, because it lets you, gives you more flexibility in your design.
Exactly, and our products are made such that it can operate with any voltage in between there, so you don't have to have set pieces of input. So it really gives people a good platform to develop up on. And in fact, the whole family that we're announcing covers a very broad space. It goes from 8K bytes to 128K bytes. It goes from 20 pins to 80 pins, and it's all the same basic peripheral sets. You know, there's maybe more on the high-end product than on the lower-end product, but people can move within that family very easily. So once they learn it, they know how to use the product, it's very easy for them to move within that family of products.
And what were those power consumption numbers again for the K22?
So our standby currents meet our XLP targets. We're seeing numbers as low as 20 nanoamps, pure static. Watchdog timer running for periodic wake-ups, you see numbers as low as 300 or so nanoamps at room temperature. And then our biggest improvements here on the dynamic current consumption side, we see numbers as low as 75 microamps per megahertz. So just to put it in perspective, our previous generations of these microcontrollers consumed almost double the power consumption that we're seeing on these new microcontrollers.
So it's a significant power savings.
It's a significant power savings, yes, indeed.
Wow, that's interesting. Now, I understand the K90 family is the same basic device, but you've added LCD controlling capability to it, the device.
Yes, so there's a 60 and an 80-pin version of the K22 style family. So all the goodness that I just mentioned on the K22 is still built in, but you have a segmented LCD drive. So the application space is slightly different. We see a lot of interest from our medical customers, a lot of the traditional thermostat, those kind of applications as well. A lot of energy metering, as you probably gather that's a pretty interesting and hot topic at the moment.
Right.
But so a lot of those require segmented LCD drive, and the K90 family of products address that need specifically.
Well, I also think that that's going to expand a great number of peripheral applications because, you ask a group of engineers about a device and you're going to hear 8 applications you never thought of. More and more devices are incorporating displays in them just for simple user interface application solutions.
Yes,
so I think the fact that you're incorporating that technology into the 8-bit is going to give a lot of tools to the engineer to be able to address some new application areas that they weren't able to address before easily.
Easily, and exactly so similar to these products that you can, for example, have the integrated LCD, and we also have, as I mentioned, the touch sensing peripheral in the charge.
The M-Touch, right?
Yeah. The specific peripheral here is the charge time measurement unit, or CTMU, which allows people to implement the M-Touch along with the segmented LCD drive for a nice, sleek-looking user interface, all integrated into one product, and there's enough memory to do a lot of other things in that same product as well. So it really allows people to build that single-chip device or single-chip application around these products.
Excellent. Well, Fanny, thank you very much for taking the time today to talk to us about this, and I'd like to thank you guys out there for taking the time to watch. So this is Alex Pault with Fanny from MicroChip. Wanted to say thanks and have a great day.